The very first spark of life on Earth. How did it truly begin? Was it some divine force breathing life into stone and water? Or was it a mysterious visitor from another world who planted the seeds of life here? Scientists have wrestled with this question for centuries, and even today it feels almost impossible to believe that something so vibrant, so full of awareness, could emerge out of lifeless matter. But the truth is far stranger, far more beautiful than the myths we once believed. Think about this for a moment. Your DNA is 60% identical to that of a banana. No, that's not a joke. It means that you and a banana share the same great hundred millionth ancestor. You go back far enough in time. In fact, this is not just true for bananas. Every single animal, plant, fungus, and microorganism you've ever seen shares a common ancestor with you. Scientists have traced all living beings back to a microbe that lived around 3.7 billion years ago. They call it LUCA, the last universal common ancestor. It wasn't the very first living thing, but it's the one that survived long enough for everything else, including us, to evolve from it. LUCA raises the real question: how could something like this, a tiny living cell, come into existence in a world that was once nothing but rocks, gases, oceans, and fire? For most of human history, the common belief was that some kind of mystical life force flowed through living things, something unique and separate from lifeless objects. But then came experiments that started to break this illusion. In the late 18th century, Antoine Lavoisier studied a guinea pig's body heat and compared it to burning coal. To his shock, both produced the same chemical results. Suddenly, life didn't look so different from non-life. A few years later, Luigi Galvani saw dead frog legs twitch when touched by metal, and he thought he discovered the spark of life itself. But Alessandro Volta proved it was just electricity from the metals, and from this discovery, he created the very first battery. Slowly, the walls separating life from non-life began to crumble. The real turning point came in 1828, when Friedrich Wöhler accidentally created an organic compound found in urine using nothing but inorganic chemicals. This shattered the belief that organic compounds could only be made inside living beings. And soon, other chemists began creating fats, alcohols, and acids artificially. It became clear that life's chemistry wasn't powered by some hidden magic. It was built out of the same building blocks as everything else, but still, there was a mystery. If life is chemistry, then what separates a living thing from a stone or a cloud of dust? What does it mean to be alive? Is it the ability to move? Then trees would be excluded. Is it the ability to reproduce? Then sterile animals like mules would not count. Scientists tried to define it in many ways, but one definition stood out. Life is self-reproduction with variation. The ability to copy itself, but with tiny changes each time. Those changes are what evolution builds upon. And if we look closer, for major features set living things apart from non-living things: complexity, metabolism, boundaries, and the power of replication. Step by step, we can trace how these emerged. But this transformation did not happen in a single flash. It was a slow spectrum, stretching over billions of years, a chain of miracles powered only by chemistry and time. First came complexity. Where could the molecules of life have come from? Some scientists believe they were delivered to Earth from space during the era of heavy bombardment, when meteors and comets rained down endlessly. This idea is known as Panspermia, and today we know it's not far-fetched. Using spectroscopy, scientists have discovered amino acids, sugars, and even alcohol drifting in interstellar clouds millions of light years away. In fact, nearly every building block of life we know has already been found in space. It's as if the universe itself is a giant warehouse filled with spare parts for life, waiting for the right conditions to bring them together. But what happened once those parts reached Earth? Imagine a bubbling pond on a young planet filled with gases and struck by lightning. This primordial soup is where many believe life began. In the 1950s, Stanley Miller and Harold Urey recreated those conditions in a glass container. After weeks of observation, They were astonished to find amino acids, the very building blocks of proteins, forming spontaneously. From lifeless chemicals, the first steps of life emerged. This is where the story truly begins. Molecules started organizing themselves, slowly moving toward replication. Clay minerals on Earth acted like scaffolds, binding small molecules together and allowing them to form long chains. Eventually, these chains became RNA, a molecule that could store information and copy itself. With RNA, life had taken its first true breath. But before we continue this journey into replication, boundaries, and metabolism, let me ask you something. If you find these mysteries of our origin as fascinating as I do, hit that subscribe button right now. Don't just watch, join this journey with me. Because the deeper we go, the more mind-bending the answers become. With RNA, the spark of replication had begun. Imagine chains of molecules floating freely in water, bumping into each other, copying themselves, and making tiny errors along the way. Those errors, those little variations, were the first seeds of evolution. But to truly become alive, something else was needed, a boundary. A way to separate the inside from the outside. Nature provided this in the form of lipids, fatty molecules that naturally gather into bubbles when placed in water. Just like soap molecules trap dirt when you wash your hands, lipids trap chemicals inside themselves, creating tiny bubbles that mimic the structure of cells. One day, an RNA molecule was caught inside such a bubble. That bubble became a protocell, a primitive cell, the ancestor of everything alive today. It wasn't fully alive yet, but it was on the path. Replication and boundaries had arrived, but life needed one more thing: energy. Without energy, nothing could keep replicating. This is where the story turns to the deep oceans of early Earth. On the seafloor, hydrothermal vents spewed scalding mineral-rich water. These vents provided a natural source of heat and nutrients. Scientists now believe that protocells absorbed energy from these vents, using it to fuel their replication and growth. Over time, this gave birth to the first true metabolism, the process of consuming and releasing energy. From here, life began to diversify. Two main groups of single-celled organisms arose: bacteria and archaea. They were different, yet both came from the same primordial roots. And billions of years later, a groundbreaking partnership between them would create something entirely new. At some point, a bacterium entered an archaeal cell. Instead of destroying each other, they formed a partnership. That bacterium eventually became the mitochondria, the tiny powerhouse that lives inside every one of your cells today. Without this merger, complex multicellular life could never have evolved. This extraordinary event gave rise to eukaryotes, the category of life that includes plants, animals, and humans. Thanks to mitochondria, cells had access to vastly more energy. With that energy, they could grow larger, develop complex DNA, and eventually form the vast diversity of life we see today. Every tree, every flower, every bird in the sky, every human being, all of it traces back to that one ancient alliance between two microbes. Think about how long this journey took. From non-living molecules to protocells, from protocells to LUCA, and from LUCA to the first multicellular organisms. It was not a sudden miracle. It was a chain of events stretching across nearly 2 billion years. By the time the first multicellular beings appeared, Earth had already been alive with single cells for over 1 billion years. And yet, if we look at the bigger picture, it's humbling. The molecules that made life possible, amino acids, sugars, lipids, nucleotides, all existed in the universe long before Earth was even formed. They were drifting in clouds of dust and gas, carried by comets, delivered by meteors. Which means, in a very real sense, you and I are made of stardust. Every heartbeat, every breath, every thought you've ever had is powered by atoms that were once forged in stars billions of years ago. So, when we ask how did life begin on Earth, the answer is both simple and profound. It began in the stars, it began in the oceans. It began in the smallest bubbles of fat trapping a strand of RNA, It began in a fragile chain of accidents, guided only by chemistry, chance, and time. And out of those accidents came everything: bananas, bees, blue whales, and you. Now, I want to hear from you. When you think about this story, about our true origin, what do you feel? Do you find it humbling, or does it make you feel more connected to the universe? Drop your thoughts in the comments below. Because at the end of the day, the story of life isn't just science, it's our story, and your voice is a part of it.